Thank you all for coming. This is a panel about applying to grad school and preparing for grad school, hosted by the Women in Physics group. So first we're going to go through each of our speakers. They're going to introduce themselves, talk about a little about what they do, what year they are, their field. Then I have some questions, some of them from you guys, but feel free, it's pretty informal, so feel free to just ask away at any point if there's something that you're dying to know about. So you want to start with Dr. Zangwill?
Sure. I'm Professor Zangwill. I'm here because I am the associate chair in charge of the graduate students, which means I chair the committee that reads all the applications. And so for that reason, at least I know something about why we choose people to come here.
My name is Bo. I am a third year now, physics. Yeah, we're all the same here. I work in Harold Kim's lab, and we work on specifically single molecule genome biophysics.
My name is Karan. I'm also a third year grad student here now, and I work with Dr. Shoemaker and work on simulating black holes.
Hi, I'm Emily. I'm also a third year grad student here. I work with Mike Schatz on physics education research, in particular TA training.
And my name's Andrea. I'm also a third year. I work with Flavio Fenton doing biophysics, complex systems, and I'm also organizer of a lot of women in physics events. Did my undergrad at Boston University and moved around a little bit before coming here. So I guess we can go ahead and start. So one major question for the students, and Dr. Zangwill, feel free to chime in for this question or why you think students should choose to go to grad school, but maybe why did each of you choose to go to grad school?
Shut the door, by the way, it's sort of a background.
So I guess I'll start. So I was an engineer, did my undergrad in engineering, biomedical engineering. Got a job very close by to my undergrad in an Air Force base, so I was civil service. And I worked as an electronics engineer, and riding a desk just killed my soul every single day. It just wasn't for me, and I knew it wasn't for me. And the fact that I would bring a copy of Townsend and read it during my lunch break, that kind of told me I think I ought to be somewhere else. And it was pretty obvious, that I really wanted to do physics instead of what I was doing.
So I came to the US just to get my undergraduate in astronomy astrophysics. And pretty much since day one of my freshman year, I knew I had to be in grad school. The only open choice was what research and which school.
So for me, I did my major in undergrad in physics, and it was with the idea that I'm going to go to grad school in astrophysics after I graduate. There was never any question of if I'm going to. I was going to. And I went to grad school in astrophysics, and I got a master's. And then I left the field. And I took a year off, and then I decided, I got interested in education, and I realized, education, outreach, physics, it's all related. I could do a PhD in physics education. And so here I am.
For me, as I said, I went to Boston University. I did some research there, but didn't quite like it, so I did a major life change and tried to apply to grad school for math. I don't know what was going through my mind at that time, but basically what had happened is I knew I wanted to continue my education. I knew I wanted to eventually teach and continue to do research. I just didn't know what in. But while I was in the math program at UT Austin, I realized I didn't quite fit there in that community. Hello.
Good morning.
I decided to take a physics class while I was there to see, is it grad school that I don't fit in with, or is it math that I don't fit in with? So I took a nonlinear physics class there, and I loved it. And I could tell because I wanted to work on those problem sets and I didn't care at all about my math homework or what we were doing in math class. So I decided to try to get in here because it's a very great program. There's a lot of interdisciplinary work and nonlinear dynamics is big here, and that was what my interest was in. So that was kind of my reason, just to further my education, continue doing research, and because there's a great community in any campus, I think. Instead of, I don't think I would do well in industry.
Well, you all know that physics is a peculiar calling. You tell people you're a physics major and either it goes silent or they say, boy, you must be really smart or you must be really stupid. So you all know that part of it. I was a junior physics major before I realized that you could get paid to do physics. I didn't know it was a job. And so once I discovered that, you then realize that, at least these days, in order to get paid to do physics, you need to go to graduate school to get the credential, the PhD. And then, wow, they pay you to go to graduate school too. That's pretty amazing, because the other people you might know interested in psychology or English or history, they gotta pay to go to graduate school. So that's, boy, that's even better. And so that's how many of us, I think, want to, and then, you know, and you're pretty good at it, and so why not? And many of us kind of tumble into it. And then after 5 years, you decide, is this really what I want to do with my life or not? Because you're at the age when a lot of things happen in your lives. And so, you know, you sort of inject yourself into this process, and then you see how it all comes out. And that's pretty much what happens with everybody.
I think the funding is something that other people need to get used to. I remember trying to tell my mom when I told her, I want to go to grad school. She said, why do you want to do more school? Like, you already have a bunch of loans. Who's going to pay for your school? I was like, well, the school's going to pay for my school. And she didn't believe me for a very long time. So just make sure you're aware of that. And you might have to try to convince some people, like, no, don't worry, it'll work out funding-wise. A lot of schools have teaching assistantships or research assistantships, fellowships. I don't know if have any of you gone through like a fellowship applying process, or I haven't, so I can't give too much feedback on how to go about looking for fellowships, but maybe Dr. Zengel, do you have any advice on fellowships applications?
Yeah, there's a limited number of them. The NSF fellowship is the best one if you could snag one. The time to apply for that is now, so you should look online about that. They're very difficult to get, I have to tell you, but it's worth trying. That's the biggest one. And there are other types of fellowships of all sorts of strange sorts. Ed, you had one of the more peculiar ones, right?
That's right. National Pool Builders Association.
Okay, so there's all kinds of organizations that do this, and if your family happens to be in some business, or your son, I went to graduate school with, my best friend is Italian from New Jersey, and he went on a fellowship which turns out it was funded by the mafia. and so he had to meet every year with the Don to tell him how he was doing. So, you know, you gotta look.
Those family ties.
Your family ties. You never know where there might be some money, so do look around.
That sounds way worse than meeting with your advisor, meeting with the Don.
Yeah, it was good. I mean, he said, he had wonderful stories. He was a very courtly gentleman.
Yeah, actually.
You know, when he wasn't ordering hits, I suppose. Anyway.
Well, not all mafia people order hits. Some of them just do like counterfeiting money. I know too much about this. Let's not go into my family. But,
They're just counterfeiters. I like it.
okay. Any questions about funding? Yes.
When you said now is the time to apply, you meant if you're a fourth year, you're graduating this year?
Yeah. It turns out that the more NSF fellowships go to rising first-year graduate students than to any group. And then first-year students can apply, and then they get some of them. And by the time you're a second-year student, you're old news and you guys are done.
Yeah.
So this is the time, actually, to look into that. And the Institute has workshops on teaching you how to write a successful NSF fellowship. I know Student Services should be able to tell you about that. Yeah.
Not about funding, but I was kind of curious about the experience of leaving higher degree seeking position and coming over here. How was that?
Do you want to talk about that first?
Well, my story is long and convoluted, and I won't bore you with it. But basically, I was in one program in grad school, and it didn't work out for me. And I left with the intention of just working on science outreach. And then, while taking time off to clear my head, forget about bad things that happened, I found out that there is, so I was already moving to Atlanta anyway for personal reasons. And I found out that there's a professor here in the department who does physics education. And a previous colleague of mine who I met randomly ran into in a conference, I mentioned to him the situation, and he said, you really should look into doing a PhD in physics education. That can really help you with outreach. And so then I started talking with Dr. Sangwell and with Mike Schatz, who is the professor who does physics education. And eventually we worked out, something that worked. And then I came here, and so I'm redoing grad school again because grad school is so fun.
So I was a similar kind of experience. I said I went to grad school for math, and I was pretty miserable there. And I think the worst part of it for me for a long time was I felt like I was a failure because I knew I wanted to leave. That's something I feel like that wasn't addressed in my undergrad. It seemed like everybody knew what they were doing, and then they were on track, and they would go to grad school and everything would turn out okay for them, but they didn't really talk about people who, maybe made the wrong choice at some point that they thought was a good choice, and then how to recover from that. So I, for a long time, just felt like, I don't know if I'm going to make it through this program. If I make it through this program, am I going to be happy with this program? Like, who do I even begin talking to about leaving or trying to, start a new program? How is that going to look? Applying to a new school, if they're going to see, hey, I started this program and left, and are they going to ask me a bunch of reasons, like questions why? So that was just upsetting me for a very long time. But I had a contact in this department. I knew one of the other grad students who was telling me all about the department and said, well, why don't you speak to Dr. Zangwell? Why don't you speak to some of the professors doing research that you're interested in? And we'll see if you can get here like the following year, or try to work your way into here. And when I visited, I think I talked to the professors that I was interested in working for first, just to get a feel of the department. And then I met with Dr. Zangwell, and we talked, and again, we found out something that worked. It was kind of stressful because I did go through first year grad school 2 years in a row. That's something I would not recommend. 1 year of first year grad school is enough. You might want to take a break, but if you're on some high and you're like, no, I just want to power through these classes and get them done, then maybe you can do that. But just letting you know, like, it's not over if you make a choice and decide you don't like that choice. It's not ending your whole career. And just talk to different people, try to figure out what your options are. I might have gotten more help from my math department if I chose to talk to them, but I was just too afraid to. But I found just talking to people, a lot of them are nice and they're not going to judge you too harshly. So, do you have any suggestions on maybe students that come to you recovering from some other program? Or
this happens all the time.
Yeah.
It's not shameful at all. And people come, everybody has a different story. Everybody has a different trajectory. And so It's really very common. So you shouldn't feel, because you think that your situation is strange and you wouldn't fit in someplace, you shouldn't let that stop you from inquiring. I mean, Andrea said it right. You have to talk to people. Keep it all bottled up inside is a very bad idea. And not just students who sometimes are a source of misinformation, particularly when they tell you, what the department is doing. It's best to talk to some representative of the department themselves. At least so you get it from the horse's mouth. It's always worth doing. There's no harm in shooting an email to someone in my position at any institution you're interested in, and just saying, here's my situation, what do you think? You're always going to get an answer. You always will. We get paid to give those answers.
Any other questions? I have a bunch, so if you want something specifically answered, feel free to jump in.
What do you think about the difference between going to grad school for like physics versus like one of the subfields, like specifically condensed matter or astro or optics or electro or something? I mean, I don't know if you can do it for just electro, but
Ask these people actually. Are you asking why they chose to come to a certain place? Or?
yeah, well, also sort of like when you get like just a physics major, does that give you more options or less options than if you were to get a very specialized one? Kind of like if you're trying to decide between a specialty and just base physics, what kind of pros and cons are there to those two choices?
So for grad school, at least, I applied to a lot of astronomy programs apart from physics. And the problem in astronomy programs is they take a very small set of people every year compared to physics. Like a typical physics program would take 20 students. I know Berkeley astronomy took only 5 students for grad school when I applied there. So, and because both the departments are usually pretty much interlinked in some of the other research, it's best to apply to physics programs.
I would add also, I was a physics undergrad, and then I went to grad school in astronomy. I took 3 astronomy classes in undergrad, and in the first year graduate courses in astronomy, they're talking about right ascension and declination and spherical coordinates and galactic coordinates and UV filters and a bunch of other stuff that I had no freaking clue what any of that was. But all of my classmates who were astronomy majors in undergrad knew it because they had many more astronomy classes. So like those basic, like the lingo, the basis of the field that I thought I knew, I didn't really know until after I took the graduate class. So that was a bit of a struggle, but it was a hurdle that lasted 1 semester, and then you got over it, and then you're immersed in it, and it's like it never happened because you're there on par with everybody else.
Astronomy is quite special, I would say. I mean, we had no astrophysics here until recently, and that's when this astronomy thing becomes relevant. We happen to have 2 people here in that area, but you're asking about, say, condensed matter. Say, you don't apply to a condensed matter department. They don't exist in the United States. They do exist in Europe, but here you apply to a physics department. You don't apply to a specialty. And you get there, you may have one in mind, but when you get there, you have all of your options are open. The astronomy thing is unusual because astronomers and astrophysicists kind of go between both astronomy and physics departments, and it's peculiar. But in no other subfield, and actually I shouldn't say that, biophysics these days is looking a lot like astronomy in that there's biophysics in physics departments, there's biophysics in all kinds of other departments. There are departments of biophysics, which is very unusual. There's no other subfield like, so there isn't a department of molecular physics or atomic physics or particle physics, but there are departments of biophysics. And so you have to make a decision there. If you're interested in biophysics, do you want to apply to a biophysics department or a physics department? Do you want to apply to an astronomy department or a physics department? But for every other subspecialty that I can think of, you're just applying to a physics department. We're getting balkanized, actually.
So I think continuing with that topic, one thing I noticed about applying to grad schools and the different application process for school is I think if I remember correctly, some schools kind of want you to pick your field when you're applying or what you're interested in, whereas I think other schools, you know, you can change what your like interests are once you get there. So I don't know if you've had any experiences with schools that maybe like wanted you to know who you wanted to work for right away, or what field right away.
Yeah, I think that's something I still want answered, actually, because, you know, it's like after the fact I came here, and it's kind of one of those things I think what the application committee wants to see is a strong interest in physics, you know, whether it be a particular subset or not, you know, just some sort of vitality in what you want. And mine happened to be biophysics, and I ended up liking the lab that I ended up working with, but, you know, there's certainly no shame in realizing this was not for me. Wow, this is totally different. I need to go to a different lab. But yeah, but I do remember, so like, I was very interested in biophysics, so I applied to Emory, because Emory was also, has, you know, very strong biophysics presence, and that's pretty much all they do. So like, if you came in there and were like, you know, hey, I'm really interested in AMO, and they would just be like, throw that away, you know, that goes right in the trash, because that's not what they do. You gotta obviously pay attention who you're applying to.
Yeah, I think when looking into grad schools that you're interested in, even if you're not exactly sure what research field you want to go into, try to contact people in the department, because I think another thing, at least that friends of mine had experienced, or they knew, you know, certain work that they were interested in being done at a certain department, applied for that work, but one person did it, he wasn't taking any more students, so that application kind of went in the garbage. But that was just one school. That's not what happens at every school, I'm sure. But so kind of look into, like, are they looking for students in this area? So, you know, is the school going to be a good fit for me? Should I spend time, you know, applying to the school if I know what I'm interested in already?
You know, different schools are different. I was just thinking I probably should amend some very, very large schools do admit by area. At least MIT, for example, used to admit, you'd be admitted into the atomic physics area. So you should look, it should be clear on the application. I think the majority of schools do not, it's like I said before, but some of the very largest schools, perhaps they do. So you want to you want to look into that. Now, on the other hand, again, if you say, well, if you have your mindset on one person, and that person says, I'm not going to be taking any students, then you should look elsewhere. But let me tell you that, you know, we ask everybody what their interest is when they come in, when they apply, and so I have that data, and then when I look back and I see who people wind up doing their PhDs for, at least half of them are in a totally different field than the one that they thought they were going to be in. And so don't think whatever you wrote down, whatever box you checked about the subfield of physics you think you want to work in, that's what you were thinking at that moment. 6 months later, you could change your mind. By the time you show up on campus, you could change your mind. And in most places, it's fine. You can change your mind, and there's no penalty. They won't kick you out. They won't terminate your stipend. You know, just so don't worry too much about that.
I mean, the department has invested in you at that point.
Yeah,
right?
exactly. Yeah.
So how did you figure out which field of physics you were interested in? Like, how early on, what made you interested in that? I guess any suggestions you can give about finding that field that you're interested in?
Okay.
Anyone can start.
Everyone looks at me. No, well, obviously, like I keep saying, I was interested in biophysics, but my background was in biomedical engineering, so specifically, I had a lot to do with bioinstrumentation and biomechanics, and so it was a lot bigger animal stuff, more like what Dan Goldman's lab would be like. And by the end of it, I realized that, you know, it really, while it was a lot of fun, it just really wouldn't be something I could continue on to do, you know, as a career-wise. And I wanted to get smaller. I really enjoyed that line between biology and physics, you know. And by the time you take, you know, a StatMed class or something, and you see all this application that can just be, you know, thrown out to a biological system, you know, that got me hooked. That was it. That moment right there, I remember, yeah, I got to go, you know, study small single molecule systems, something like that.
think for me it was almost consequential. I started working on gravitational waves since a freshman, and in sophomore I went to the Albert Einstein Institute, and again I worked on gravity. After that I went to Perimeter Institute where I worked on quantum gravity, in gravity, then worked on quantum cosmology. So I was just linking towards more gravity or things related to that. Eventually by the time I was graduating, I didn't feel comfortable actually changing of field. I was very happy being in gravitational waves or gravity.
Well, I've already mentioned, I mean, I liked astronomy since I was little. The first time I realized there's constellations, I was hooked. And I kept reading popular astronomy and all those things that I thought made me prepared for astronomy grad school, but not quite really. And then in astronomy grad school, I just continued more towards a theoretical, phenomenological path. I was doing black hole mergers, simulations of black hole mergers. But then during all this time, I also really liked explaining things and teaching things. And I like the idea of popularizing science, but in a more solid, meaty kind of way, not like, oh, there's these strings, ooh, but like something more, you know, digestible. And so when I realized I wasn't going to continue doing research in astronomy, I realized education is the field for me. I like explaining things, I like teaching things, and I like bringing science to people. And so then that's how the changing gears happened for me.
For me, it was kind of trial and error. So my university in undergrad encouraged research as early as possible, but when you're taking like intro physics courses, you don't know too much physics, so how do you start picking a research field? But I started out just doing, I think like, I forget, I was just doing like some kind of setting up lab equipment stuff in someone's lab. I don't even remember what they were doing, because like, I don't even think it was ever explained to me at the time. It was just like, sure, I'll teach you some things on Excel and you can help us do this. But then I got my first actual research position through a REU, which is a research experience for undergrad. For those of you that don't know, it's summer research where you get paid. It's kind of like 8 to 10 weeks depending on the program. And they're just at different institutes all over the US, and you work there with a bunch of other students that are also in that program, and they set you up with a research advisor, and you hopefully have a project that you can work on during that time. But you know, so it's kind of impossible to give like an end date for a project, so sometimes, you know, you just get experience even if you don't get any results out of it. It really depends on you and your advisor and what the project is. But so that kind of really got my foot in the door, and I was doing graphene research, which I had no idea any of the stuff that they were telling me about, you know, and what was going on at the quantum level and these Dirac cones. And I was just like, I don't know, I just got out of freshman EM, I don't know, but I got a lot of like lab experience, hands-on experience, and I really liked the hands-on experience. So I knew that I wanted to go towards like experiment instead of theory. But then I, you know, continued. I had read like, you know, particle physics books that seemed cool and you know, stuff going on at the LHC. So I did some particle physics simulations at my undergrad. Particle physics was like a big field at my undergrad, so I think every student there touches it at some point. But you know, I found that field to be too big. We actually had a study abroad program at the LHC, and while that was like an amazing experience, it's just a huge collaboration, and I realized, you know, there's another aspect to research I have to think about, like what sort of group do I want to be in? Do I want to work with this group where, you know, it's people from all over the world working together, having to make every little piece fit together in order for this to work, which is very difficult to do. And you know, like silly things that were going on, like they didn't have me on the right experiment for months. Like they had me listed as CMS even though I was technically working on Atlas, so I didn't have access to the Atlas files and all that, even though I like talked to many different people here and there, and I was just like, I don't want to deal with this. I want to work on like a smaller project that, you know, a few people in my lab, maybe a few other schools we collaborate with, but this is just too big for me. Went back to my undergrad after the study abroad. Wasn't quite sure which area of physics to go into next, but I took a chaos class in the math department. But I was like, I really like this stuff. I want to learn more about this stuff, and I think that's probably where it's like, oh, maybe I should try math school. Yeah. But then, you know, I realized like there's this whole area of kind of chaos and nonlinear dynamics in physics that I just was not aware about in my during my undergrad, and you know, it was connected to biophysics, which I also didn't hear too much about in my undergrad, and I thought that that was really interesting. And you know, I'm doing experiments, I'm also doing simulations, which I think are both pretty cool. So I'm really happy with what I'm doing now, but you know, it was a long process to get from graphene and now biophysics. So. Yeah.
Dr. Zangwill, what would you say the #1 mistake that applicants to grad school make?
They haven't bothered to look at all at the school that they're applying to. Someone applies here, for example, and says, I'm really excited to do experimental nuclear physics. And I take that application and I just, you know, they didn't even bother to look to see that we don't do that at all, for example. So that's the biggest mistake you can make, is that sort of a thing, I would say. You have to do some minimal research and have some sense of why you're applying to a place. The other thing is that, particularly in the letters that you're asked to write, the essays, you know, a generic essay, which obviously is the same one that went to every place, and once again doesn't make the slightest reference to why you might want to be at this particular place, is another mistake, I would say. I mean, you don't have to say, I want to work with Professor X, but you might say, I find the fact that you do this and this type of physics interesting. I haven't decided between the two, but that's one of the reasons I want to come, because you do them both, that sort of thing. It only can be the tiniest little thing to suggest that you've done epsilon's worth of research. You'd be surprised how many people just don't do that elementary little thing. That's, I guess, the biggest one.
So kind of connecting with that, for the grad students, what do you think is the most essential part, or what was the important part when you were applying? Like, do you think it was trying to find the recommendations, or like the experience that you had, or your letters, and then maybe, I don't know, we can talk about that again.
Yeah, so, you know, not really being in a physics culture, it was a little daunting setting out, not really sure exactly what to do, and even being removed from academia for 2 years, that just, the whole idea of going back was a little scary. Because you've lost touch with your professors, they don't really, remember you, but you know, they don't really remember you because they see 1,000 students every day. Well, what was my point? So just trying to get back into it, the whole thing was very scary. So the whole idea that I had was just really find the schools that I really wanted to work into. Part of it was constrained for personal reasons. You know, I had my wife with me, and she was also trying to go back to graduate school, so trying to coordinate, you know, areas that we can both go into. Atlanta was a big area, so she has areas she can look into. The research triangle, that was another big area that we looked into. So there were constraints, you know, externally that you guys probably wanted to deal with. But the biggest thing was really finding the schools that really had the interest that I was concerned with.
Let's see. I think at the end, so I applied as an international student, which is a little different than applying as a regular student, because just the percentile scale of physics GRE and everything that shoots up when you're an international. But at the end, the thing that worked is the one who writes recommendation letter. They know people in the school you're applying. I think that is settled. If you meet someone at the conference and you are interested in their work and have already told them, and your recommendation writer also knows that link, for me, I think the schools that I applied were more than just applying to a department where nobody knows your recommendation writer. Even if you have an application, it's hard to convince.
Well, for me, the first time around, my first big decision was applying to physics departments or astronomy departments. I ended up applying more or less evenly to both physics department that had astrophysics programs and then astronomy departments on their own. But I think one thing that really helped me is I had 3 REUs under my belt by the time I was applying to grad school the first time around, and they were in different areas. I was doing pulsar research, I was doing X-ray calorimetry in NASA, and I had done red giant evolution. So I had letter of recommendation from people in different fields, and I thought that that showed that I was versatile, I guess, that I was interested in astronomy and that I was willing to put in the work and do the research, and so then my letters of recommendation were from these like very different fields, areas, I guess, subfields, sub-areas. But yeah, it was, I think the biggest thing was about choosing astro or physics with astro.
So I think for me, when I applied, at least for math, the most important thing that I focused on was my personal statement. So, I mean, as a few of the panelists already mentioned, you know, we all are coming from a different place. We have different personal issues. So, you know, maybe our grades and our experiences aren't like the greatest. So I felt like I had to